An implosion. An implosion refers to the process or event in which an object collapses inwardly due to the external pressure exceeding the pressure internally. This occurs when the forces acting on the object from the outside become greater than its ability to resist or withstand those external forces. These collapses typically involve inward deformation, which often leads to complete destruction or severe damage.
In recent news, there has been a tragic incident involving the implosion of the Titan submarine. Our hearts go out to the family and friends of the victims during this difficult time. And this occurrence has raised the question, what could cause a submarine to implode? But to first answer this question, we have to know what exactly is a submarine, and how does it work?
Submarines are complex underwater vessels that are designed to operate beneath the surface of the water. They are capable of traveling long distances, remaining submerged for extended periods, and carrying out various missions such as military operations, scientific research, and exploration. Let's take a look at the basic components that make up a submarine and learn the principles behind how they work. 1. Let's start with the body of the vessel, which is referred to as the hull. The hull is typically cylindrical in shape and made of strong steel or other pressure-resistant materials. The hull provides the structure and ensures the integrity of the submarine in high-pressure environments. 2. Ballast tanks. Submarines use ballast tanks to control their buoyancy. By filling these tanks with water, the submarine becomes heavier and sinks. To rise to the surface, the water is pumped out of the tanks and replaced with air, reducing the overall weight of the vessel.
3. Propulsion. Submarines employ various methods of propulsion, including diesel-electric engines or nuclear reactors. Diesel-electric submarines use diesel engines to power generators, which in turn produce electricity to drive electric motors that propel the submarine. Next up at 4. Navigational and control systems. Submarines rely on a wide array of navigational and control systems. These include radar, sonar systems to detect and locate objects underwater, and periscopes for surface-level observations, as well as gyroscopes for maintaining stability, and complex control mechanisms to adjust depth, course, and speed. And even some advanced submarines can have special sensors, silencing technology, and even special weapons, such as torpedoes.
Someone give me something.
Torpedoes are ready.
Then launch them!
As well as missiles, advanced sensors for surveillance, target acquisition, threat detection, sound insulation, vibration reduction, and even quiet propulsion are just a few of the advancements a submarine can have.
And last, but certainly not least, 5. Life support systems. Submarines are self-contained environments and must support the crew's life functions. Submarines can provide oxygen a number of different ways, from oxygen generation, where submarines have onboard systems that can generate oxygen, or air scrubbing, where submarines also can remove the carbon dioxide or CO2 from the air inside the vessel. Another method is air recycling. Rather than constantly generating new oxygen, submarines recycle the air by removing CO2 and replenishing oxygen levels. Carbon dioxide absorption. CO2 is absorbed using various chemical agents, such as lithium hydroxide, effectively removing CO2 from the air. Or Old Faithful, oxygen storage. Submarines can just carry a supply of compressed or liquid oxygen in case of emergencies or when the oxygen demand exceeds the production capacity. It's important to note that submarines have limited resources and cannot remain submerged indefinitely. Eventually, they need to resurface to replenish their oxygen supplies, food, and other consumables. Okay, now that we understand what a submarine is and how it works, let's go back to the first question: what could cause a submarine to implode?
Great question. I couldn't have asked it better myself. Submarines are specifically engineered to withstand the immense pressures found in deep-sea environments, mainly through the design of their hulls. The hull acts as a protective barrier against external water pressure, preventing the submarine from being crushed. Traditional submarine technology relies on well-studied materials like steel, titanium, and aluminum, known for their performance under extreme stress. In contrast, the Titan submarine featured an experimental hull design that primarily utilized carbon fibers. Carbon fibers were chosen for their lighter weight, allowing for increased passenger space. However, their properties for deep-sea applications are not as well understood. Carbon fibers can be prone to sudden cracking and breaking, posing a significant risk. Additionally, the Titan had undergone numerous deep-sea dives, which gradually contributed to fatigue and wear on the hull. This accumulation of fatigue likely played a role in the submarine's inability to withstand the intense pressures it encountered. It's crucial to highlight that navigating extreme depths poses a significant engineering challenge. Extensive research, testing, and understanding of materials are essential to ensure the safety and integrity of submarines operating in such environments. The most significant factor is the immense water pressure at great depths, which can exceed the structural strength of the submarine's hull. If a submarine exceeds its design limits and dives beyond its maximum operating depth, the external pressure can surpass the hull's ability to withstand it, leading to implosion. Additionally, any damage or weaknesses in the hull, such as cracks or structural defects, can act as stress concentrators, making the submarine more vulnerable to implosion.
Well, there you have it. It's important to note that submarine technology is continuously advancing to enhance safety and structural integrity, and thorough inspections and maintenance are crucial to minimize the risk of implosion. And remember, any objects that are designed to be strong, with the right amount of pressure from the outside, they will collapse or break apart. Well, thanks for watching. Please subscribe to Mind Muscle TV for more educational videos just like this, and remember, you're getting smarter every day.
And as always, stay curious.